video, I'm going to show a fact that we are using in class when looking at the limit of a set of Riemann sums that we're putting together. This is saying that if we sum up squares, 1 squared plus 2 squared plus 3 squared, all the way up to n squared, we should be able to have this fraction on the right-hand side as a total of the summation. To make some of the calculations easier, I'm going to consider the factored version of this fraction. I'll write it over here. I want to look at this by induction, so I'll start by considering the base case, which is when n is equal to 1. So putting a 1 up here, and I want to show that if I plug 1 in, let's use this version here. If I plug 1 in, that this summation will be true, or this equation will be true. So here I'd have what, 2 plus 3 plus 1 over 6. The only number I'm plugging in here is 1, so 1 squared is equal to 6 over 6. Yeah, that's true. Then I'll assume that it's true for 2 squared, for n equals 2, n equals 3, so on, all the way up to the n minus first case. So let's assume that this is true up to n minus 1. So then we're going to say, well, okay, if I sum this up to n minus 1, then I could use that fraction, and this is where I'm going to use the factored version. It would be n minus 1, and then I'll have n minus 1 plus 1, and then 2n minus 1 plus 1. I'll show you what I'm doing in a second. I'm just taking n minus 1, and I'm plugging it into this version of the fraction. I did that so I didn't have to cube n minus 1 there. Okay, so let me get rid of those highlights. All right, so let's simplify this. This is n minus 1 for our first factor, and then just n for the second factor. And then that's going to be 2n minus 2 minus 1 over 6. Okay, so we're going to assume that that part is true. And then let's think about what happens at the nth stage. So the summation as I goes from 1 to n, I'm going to split this up and say, well, that would be the same as adding up the terms up to n minus 1 and then adding n squared onto the end of it, right? So now, instead of writing this, I'm going to write this fraction that I just put together. So I'll make a little substitution here. Let's say that this is n minus 1 times n, 2n minus 1 over 6. And then I'm tacking on this n squared. If I multiply that numerator out, I'll have n, let's see, n squared minus n, 2n minus 1. I'm going to write this n squared as 6n squared over 6 because I know I want to combine those fractions together. And then this is, let's see, 2n cubed minus 2n squared, and then plus n, and I'll put a plus 6n squared here. Combining like terms, And way back up here, we said that we were starting with, back up here, we started with the summation as I goes from 1 to n of I squared. And it looks like this is what we were trying to prove. So we're done. All right, thanks for watching. If you have questions, ask me in class.